problems for us. Okay, so you guys you've seen this. You've seen these equations before. We know a little bit about it already. Now we just have to graph it. So this is 1, 3, 2. This is the last section in lesson 3. So we're moving along. After this, actually, we only have like 2, 3 more lessons. It's not so much. Okay, for Unit 1. Okay, so we know that growth and decay, we start here. A out in front is always the initial. It's the initial amount. You start with 3 rabbits, you have 3 out there. This is our multiplier, which when we combine the rate as a decimal, either adding it to 1 or subtracting it from 1, then that is called our multiplier. That's going to be our growth or decay factor. Okay. This is time, and I'll tell you, this is the crux. This is the hardest part. For this lesson, figuring out the time units is the hardest part, but everything else, I'm pretty confident. You guys can do this. We just have to get this down. You guys already know how to graph using a table, right? You plug in one value, you get your other value, you plot those points. So the hardest part, again, is figuring out our time, okay? So you already know how to do this. You've seen this before. With time, and actually I'm going to read these here, but when I get down to this key, it's actually a little bit more important. But if the problem stated every 6 days, right, we'd enter for time x over 6. The reason being is if I make a graph, and this is the next key point here, you have to decide what your values for x, because x in this case is our time. If it was every 6 days, I'd put this as days. Right? So here's 6 days right there. Okay. So if it states every 6 days, and this is why maybe these are rabbits. I'm looking at how many rabbits I'm able to breed. Every 6 days, it wouldn't double. Rabbits don't make that. They don't have babies that quick. But if, say, it was, grasshoppers or worms or something that really multiplies really quick, after 1 day, if we're talking about worms doubling in population every 6 days, after 1 day, would it have doubled? Would it have doubled in 1 day? It says it doubles every 6 days, so after 1, have we doubled yet? No. How about after 2? No. 3? 4? 5? 6? After 6 days, it doubles, right? So after 6 days, essentially, I would have 1 unit, because it would be 6 over 6. I would end up with 1 unit of change. Okay. So when we've established it here as days, I know that up here for x, for my time, I have to make it x over 6. So I'll just put time. For time, it'd be x over 6. We're going to practice that a bunch of times with the practice problems here. Okay. Any questions on that? I know that that's going to be like thumb sideways right now. Is it thumb sideways? It's thumb sideways. Okay. If it were to state this instead, if it stated twice per year, right? Twice per year. So if I'm looking at that and I'm going twice per year, then watch this. Okay. Let's make it years. If you had 1 year, okay? If it is, let's say, you have the worms double twice a year. It's a slow-growing worm. It's cold environment. Let's see. Twice per year. How about, let's see, if I was right here at 6 months, would it have doubled yet? The worms population doubles twice per year. Yes. Good instinct. So at 6 months, at half of a year, right, it's already doubled. If I started at 10, then half a year, it would be here at 20, and it would double again up here to 40 by year 1. Because my units are in years, and I'm saying it doubles twice a year. Twice a year is the key. Twice a year. Twice per year. So that would be, thanks, time is 2x. You see? If I have my x values in years, and it is going to double the population of worms twice per year. That means halfway through the year, it's already doubled. Halfway more through the year, it's doubled from that amount. And it keeps doubling every half year. So my units are in years, so I need to make time 2x because it's twice per year. Twice per year, years are by x, 2x. Little bit, now we're here still, huh? We're here, somewhere in the middle. Okay. Let's look at this problem together. Let's see if we can figure the whole thing out. So this problem over here says, a rabbit population grows at a rate of 12% every 3 months. The population starts at 100 rabbits. Create an equation and graph it. Okay. So first off, we have to decide, if we were going to graph it right here, what should we put here for our units for x? What do you think? Because here's the deal. You could choose to put in seconds, minutes, days, weeks, months, years, decades, centuries, millennia, eons. That's all I know. I don't know what's bigger than an eon. Doesn't matter. Okay. What should we put down here? Tell your neighbor what units are we going to use for this axis right here. That's going to help us know what time is going to be. It says every 3 months. That might be a hint. You could think of it as, there's 2 right answers to this. Okay? No, there's a bunch of right answers, but we're going to pick the most appropriate, the easiest one. Okay, for a strawberry, watermelon, Isabel. What should we use? Months. I like this. It's pretty easy. It usually matches. It usually matches the units in the problem. Sometimes it's going to be helpful to see it in a different way. Right? So I'm going to put this as months. Okay. So if it grows by 12% every 3 months, has it grown by 12% after 1 month? No. It's not gotten there yet. How many months do we need in order for it to grow 1 unit of this 12% growth? 3 months. Okay, so we're going to express time right up here as what? Tell your neighbor what you think. What you think. Remember, if I have 1 month, I don't get that 12% growth. I need how many months? 3. So you need a way to be able to visualize. Think about, have I reached my 3-month window, and then I get a 12%. 3-month window, 12%. Still hard. I understand. Still tricky. Do a couple more problems like this too. Let's see. For a blueberry lemonade starburst, what group has a good answer? Yes, Loretta. Loretta, did your hand up? Yeah. Oh. I didn't hear what you said. I thought you said, excuse me. I said 6 months. 6 months? Yeah. Okay. Let's see. So 6x? Yeah. Okay. We'll keep this idea up here. Let's see if we had another idea. Genevieve, what do you think?
I think that is
okay. That's short? Sorry.
Time
went almost back.
Is x divided by 3.
Yeah. X divided by 3. Because my units are in months, I decided my x-axis is in months. I'm going to make it x over 3 because after 1 month, I haven't got my 12% growth. Right? At 1 month, right? At 1 month when x equals 1, my time would be 1/3. My exponent would be 1/3. I haven't gotten through the 3 months that I need in order to have this growth. So we have our time. That's the hardest part. The initial A, what is that A is? Really focus. I think everybody can get this. We do a couple more sample problems. Even if you're here, just stay focused, okay? Genevieve.
A is 100.
100 starts at 100, okay? Now, what is 12%? Everybody focus right here. 12% is what in decimals?
0.12.
Perfect. right? Okay. Let's see, what else do we need? We know the rate, we know the initial, we have an idea about the time, so let's see if we could do it. Y is equal to 100. Oh, we had the rate. The rate R is 0.12. Is this a growth or a decay problem? We should have said that first. It's growth. That's not hard, right? All right, so it's going to be 0.12 plus 1, because with growth we choose the option of adding the rate versus minusing the rate with decay. Okay, so we're going to have 1.12. And then what goes on the outside? Okay, that rational exponent, don't worry about it. We're just plugging in. We're just going to plug in. We're going to be able to quickly graph this. I'm going to go ahead and put it over here, ready for it. Let's see if we can get this rabbit stuff here. All right, so we have months. Okay, we have this equal. Hey, get over here. All right, we have this equation we just came up with. Y is equal to 100, 1.12, x to the third. Okay. Now, we're going to graph this just like in 8th grade. 8th grade math. You plug in an x, you plug in some values for x. 0, 1, 2, 3. We're going to get our y values. That's enough to have some points and to graph this. Okay, so we've already set it up. We're ready to go. And now you just have to do a couple of these quick problems. Everybody get out your calculator, please. Remember, calculator's on Friday for the quiz. If you need one, go ahead and come on up. There's some like down here underneath my visual part. Yeah, just grab one. They're all kind of back there. Okay, looks good, looks good. Look what I've set up right now. I'm still holding this. All right, so what did I plug in first? What did I plug in? 0 for x. What is 0 over 3? What does just that fraction give us? 0. Anything raised to the 0 power is? 1, 1, 1? 111? So all this right here is going to be 1. Anything raised to the 0 is 1. Anything to the 0 is 1. It's a weird exponent rule. You know, it's just, there's a way to describe it, but we'll hold off for a second. That's not the topic here. We have y is equal to 100. So at 0, it's at 100. Does that make sense? At time is equal to 0, we start at 100. So here's the deal. For the 0, you can just put whatever the initial amount was. You didn't even have to really work this out because you know that's given. That's for sure given. Let's make this 100 down here. Let's make this 0. What's next? What's next?
The 1.
Z1. 100 times 1.12 to the 1/3. Uh-oh. Does everybody know how to add like an exponent, like to the 5th power, to the 10th power? It's that little chevron, right? It's a little chevron. So if you want, you could try it. Let's see if it works on your calculators. You might have to do the chevron symbol, bracket, 1 divided by 3. 1 divided by 3. That should get you there. You might also do 1.12 raised to the, right, 0.3333. Do like a few numbers like that. That's 1/3. You can do either of those. Check with your partner, actually. Check with the person next to you. Make sure they know the syntax for that, how to enter that into the calculator. Call me over if you're not sure on that. All right, good helping. I'm starting to see people help more in this class. You guys are awesome to help each other out. So for yours, I'm confused on yours.
That actually looks like you did it. Did you get that answer?
You guys gotta look at the answer, see the method.
That's actually always
Because that'll just be that same function. Yeah. On that guy, I think it's like x equals y. So that's the same as the shape. Okay. Okay. We'll have more practice with that. Let's bring it back. Who got us an answer for this part was like 1.038 or something like that?
Yeah.
Times 100 is?
Wait, yeah.
Wait, you can't have 1.8.
Say one more time. Can't have?
Can't have.
Good. So we don't round up. We round down because you try to. No, I'm not going to do that one. Never mind. It's going to make a joke. What is the number then, Lee? 137?
137.
Is this a growth problem? It's a growth problem, though. So 1.12 raised to the third was like 1.0 something, right? And then times that by 100. You got 100 and what?
I got
103. So you did the exponent first. Keep that answer. Just multiply by 100. Equals, so this is raised to the first power divided. Yes. All right. As folks are helping each other out, we are going to continue here. We're going to continue. Let's see. We had 1 year, or 0 year. First year, we have it at 103. All right. Well, I did bad. When you see that you just made a bad first point, you can move it, start it up here instead. All right. What's next? Second power. Y is equal to all right, remember, this one's going to be 1.12. If you're doing the same path, you want to do parentheses 2 divided by 3 as the parentheses for that exponent. You could also just say it's raised to the 0.6667. That'd work too. It's pretty approximate. We're not going to have to count half rabbits. So it's okay to be somewhat approximate. Okay, I want to give a little bit of time for classwork, so let's work really hard, diligently. Check with your neighbor right away. Once you have it, always check right away. 5 seconds, we're going to come back. See how you did. So 120, that makes sense. Yeah, that makes sense. That's okay, are we getting it? Is this just calculator problems at this point? Calculator issues? Hi, Jordan. Did you get 107 too? 107 as well. So actually we end up with 107. Now let's do it at 3. 3 is going to be pretty quick. I'm going to have us do one more after this. We just got 103. We got 107. I want to see what's happening out at let's go out at like 6 years. The third one should be pretty quick here when we do the next one. Y is equal to 100, 1.12. 3 over 3 is equal to what? 1. 1.12 raised to the 1. First power is 1.12. Times 100 is 112.
Right.
All right, I still want to do 6. Let's do 6. I'm going to see what's happening out here at 6. So 6 we'd end up with, so this was 112. Y is equal to 100 times 1.12. 6 over 3 reduces 2. So just raise that to exponent 2. And two, 124. Really more? Oh, jeez. All right, what is 1.12 squared? You guys got that? You got it on a calculator at least, right?
Yes.
Times 100 gives us? Did you round up? That's right, huh? Ah, that's why. I was doing it in my head and forgot that. That happens. 125. So at 6 years, this is not to scale, and I apologize. But the key is that it is rounding up. It's going up. We learned linear equations last year, and that would be if, let's see, if there was one new bunny every year, it would just be a straight line. 1 year, one bunny. 1 year, one bunny. 1 year, one bunny. So that would just be a straight line. Okay.
Yeah.
Exponential growth is slightly different because
Curve.
it has a curve to it. Actually, that's fine to think of it that way. All right. Are we starting to get it thumbs up, sideways, down now? Thumbs up, sideways, down now. Okay. So I want to actually get you going on classwork. You guys have about 12 minutes. Let's stay in the seat so we can be most efficient. Do we want to tell people to subscribe or what?
Subscribe.
Let's do it louder. 1, 2, 3.
Subscribe.
That's pretty loud.